Before we look at the with statement for writing to a file, let's consider this computer program that we looked at earlier in the playlist. I'm going to consider the execution of this computer program by referencing the schematic diagram that's coming into view now. This program is shown here in the schematic diagram. We know we have the operating system that has a relationship to this text file, which is stored in the file system of the operating system. And if you look at the name of this text file, you can see it reflected here in the computer program. This is the first line of the program to execute, and the string hello world will be assigned to the variable that I've called data. And I'm going to show that appearing in the schematic diagram here. This program statement is then executed, and we can see we're using the open this text file for writing. And this will create a stream that I'm showing coming into view now. And this will be assigned to my file. So my file will become the object reference to the stream that you've seen just appearing in the schematic diagram. So I'll show this by the following label telling us that it's called my file because of the name that appears here. And we need to reflect on the fact that this stream is in fact an object. And because it is an object, we could use methods associated with that object. This is the next program statement to execute, and you can see it referring to the stream, and it is invoking the write method, and it's going to transfer the data passed to this write method as illustrated in the diagram below. And you can see the hello world has been sent to the file called file to store data.txt. This is the next program statement to execute, and you can see it's referring to the stream and it's invoking the close method, and this will remove the stream from the Python code to the file to store data text file. And I'll illustrate that in the diagram below, and you can see the stream has been removed. So there is now no connection between the Python code and the file. And all of the resources that were associated with that stream have also been released, freeing up more memory space to be used by the operating system and the Python code. In other words, you've stopped memory leakage occurring. Now, if you look at the schematic diagram, you can see there is now no connection between the Python code and the text file, but it is clear that the operating system still has a relationship to the text file, and in fact the text file will be part of the file system of the operating system. So I can now go to an appropriate editor and open this file, and what we will see in the file is what's shown here. And note, there's the file name, and here we have hello world. So we can see that the data was successfully saved to the text file. Let's compare this computer program to the one that's floating into view. We can see that the first line of both programs is where we set up the data variable to hold the string hello world. We then can look to the open statement, and we can see they are identical. We can then look to this where we can see we're writing, in both cases, the data to the file. If you look at this computer program, you can see it has this program statement that will close the stream, thus breaking the connection between the Python program and the text file. Whereas if you look to this computer program, you will see that there is no statement that has the close method invoked. And that's because what we have here is a context manager. And because we're opening a file here for writing, The with statement knows that the context is file access. So it will take care of closing any streams that were open when the with statement finishes its execution. It knows that it has to close any streams that have been opened. So let's take a closer look at this computer program. The first program statement sets up a variable with content that we're going to store in a file. If we look at this, this is the with statement, and it's an example of a context manager. And if we look at the features of this, we can see we have this word with, followed here by as, and at the end you can see there is a colon. And what you have got indented here is the code block of the with statement, which means this is what will be executed within the with statement. And here there's only one line, but there can be more lines. And even when there's just a one line, we call it the code block of the with statement. So you can read this line as follows: with this file open as write access, create a stream and call it this name, my file. When you've done that, write via the stream the data to the file. Let's reflect the execution of this program onto the schematic diagram. You can see this is the Python code that I'm showing here, and we know that the operating system will have a relationship to this file, which is the file declared here in the code. This is the program statement that will execute first, and I'm going to reflect its execution onto the schematic diagram as you see here. This is the next program statement to execute, and it's going to create a stream between the Python program and the text file called file to store data, and you'll see that appearing in the schematic diagram now. The label floating into position is telling us that this stream is called my file because of what we placed here in the code. And it is an example of an object reference. So this is the object reference to the stream. And we need to bear in mind that this stream is also an example of an object, which means it has associated with it methods that we can call upon. So this line of the with statement has performed its function. It's created the stream, and the stream is a stream that will allow for information to be written to the file. And once that has been achieved, then we can execute the code block within the with statement, which is this code block here. Now, in this case, the code block is just one program statement. And you can see what it's going to do is use the stream, invoke the write method to transfer the data from the program to the text file. And we can animate that in the schematic diagram as shown now. And there you can see the data has been sent to the file to store data.txt file for storing. Once the code block has finished its execution, then we can say that the with statement has finished its execution. And because the with statement is an example of a context manager, and it knows the context in which it is operating, i.e. it's operating with access to files, then it knows it's opened the file, so it now knows it needs to close the file. And you note carefully, if you look at this with, there is no close method invoked. And that's because the with knows to close the stream. So if you keep your eye on the schematic animation, you should see that when this finishes executing, the stream disappears together with all of the resources. So now we can see that the Python code has no relationship to the text file because the stream has been removed. But note that the operating system still has a relationship with the text file because the text file is part of the file system of the operating system. So we can go to an appropriate editor and open this file, and what you will see in the file is the following. You'll note that the name of the file is file to store data.txt, and within that file you'll note that it says hello world, which is precisely what I was expecting to see there because that's the data I initially set up here on the first line of the computer program. I will finish off by comparing this computer program with the one that we saw right at the beginning of this video, which is this here, and observe both programs, and you'll note that one of them has to close the file explicitly here, whereas when you use the with, you don't have to invoke the close method. The with statement, which I'll repeat, is an example of a context manager, will do that for you.